Good afternoon, dear workshop participants. I represent the Space Research Institute of the Russian Academy of Sciences, and in my presentation I will be discussing our experience in development and usage of forest monitoring informational systems based on satellite data. The main functions of forest monitoring are as follows: mapping and assessment of forest characteristics, such as forest type, forest species, growing stock volume, projective cover, and others. Forest and burn severity monitoring, forest health monitoring, forest logging monitoring, reforestation monitoring, forest carbon budget assessment and monitoring, and climate-related forest changes monitoring. Here you can see the concept of forest monitoring system that include mentioned above components, and my further presentation will be focused on our experience of development and using of forest fire monitoring system. SDM-RS is forest fire remote monitoring informational system development for Russian Forest Agency by a number of science organizations. This is online system that provides to user the large amount of satellite data and satellite products, which are used for forest fire monitoring. The system has come a long way from concept to implementation and usage by Russian Forest Agency units, which are responsible for fire monitoring and fire suppression. The main functions of ESDM system are the following: operational forest fire monitoring that include the hotspot detection, monitoring and controlling the dynamics of fire spread, and prediction of individual hotspot spread. Fire danger level monitoring that include the weather-related fire danger level assessment, forest fire occurrence and spread assessment, and fire regime mapping. Burnt area assessment in system was realized three-level burnt area assessment scheme include a hotspot-based rapid burnt area mapping, reflection data-based burnt area mapping, and it is important to clarify that these two approaches are fully automated. High-resolution burnt area mapping, which is performed by system users in semi-automatic mode, and burn severity assessment. And another important component is forest fire suppression informational support that includes assessment of means for forest fire suppression, optimization of means usage with considering of fire danger level and weather, and causes assessments of large forest fires. The slide shows an example of fire spread simulation in ESDM system. Fire front forecast shown by the red line. The model based on simulation of fire spread from detected hotspot pixels, which are shown by the shaded area. And when model receives new hotspot data, it takes it into account in further modeling. The model uses as input meteorological information such as wind speed, wind direction, precipitation, and temperature. Also, model has a different coefficients of fire speed for different land cover types. The main purpose of the model is to assess if there are some dangers for infrastructure or for population. The next thing I want to tell is approach for tree mortality monitoring and prediction based on development remote sensing technologies. On the first step, there are only detected hotspots, and then the fire spread model is using to receive fire spread forecast. And the next step is use of tree mortality statistical model to receive tree mortality forecast. This model based on multi-annual statistical data of tree mortality probability depending on forest type and seasonality of fire. So we can receive tree mortality operational forecast, which can be used for fire suppression decisions. When the fire is over and burnt area data assessment received, we can use tree mortality statistical model for post-fire tree mortality forecast. And the final step is tree mortality assessment using development method in the end of the fire season. This data can be used for environmental assessments and for refinement of tree mortality model parameters. The next thing I want to tell you is forest fire suppression informational support. When fire was detected using hotspots data, weather and land cover condition data are used for fire spread forecasting. The assessments of potential threats to infrastructure and population with assessment of necessary means for fire suppression is being implemented. In case of threats for population and infrastructure, the decision for fire suppression can be made. In case of no threats, potential damage and losses assessments will be evaluated. And if losses exceed expenses, decision for fire suppression can be made. If expenses exceed losses, forest fire spread monitoring continues. There is some information about some satellite data-based products which use it in SDM system. The annual Russian land cover map, which used for separation of forest areas, for forest burnt area assessment, and for tree mortality model implementation. The maps has over 30 classes, including 8 forest classes, and these maps are updated with an annual frequency. The annual Russian forest species maps with 20 forest species classes, and these maps used for fire-induced assessments of potential losses. And annual Russian growing stock volume maps, which are used for fire-induced assessments of potential losses. The next thing I want to tell you is about our experience in regional forest monitoring system development and usage. We developed a regional forest monitoring system for Primorye region, and this system is being used by regional organizations that are responsible for forest monitoring and protection. The system has functions of wildfire monitoring mentioned above, and it also included technologies of regional forest mapping based on relatively high resolution satellite data. Here you can see some examples of regional remote sensing products are being used in the system. The remote sensing cloud-free composite image for Primorye region based on ProbaV data, regional land cover map, regional forest species map, and regional growing stock map. The system also has some specific functions, in particular forest resources assessments on leased plots. There is high-resolution maps obtained SHAM, and these maps can be combined with leased plots boundaries for further assessment of forest characteristics on these plots. There is also the function for comparing forest characteristics obtained using inventory data and remote sensing data. For example, for comparing of forest species and growing stock data. In my presentation, I tried to show how remote sensing data and technologies integrated into associated system can be used for complicated forest monitoring. So thank you for your attention.